Again, I welcome you all again, to our TikTok Tech Immersion Day 4. So are you excited about today's QA session? So we start our testing journey from today. Okay, that's great, Enzo. So I'm going to do a very simple introduction of the three speakers that you already see on the screen, a brief introduction to their backgrounds, and then I will bring you back to them. So today's session is about software testing fundamentals. In my layman's opinion, I think this is probably one of the easiest classes to follow, as opposed to what you've been through last week. So the first speaker we have is James Teo. So James joined TikTok in January 2022. He focuses on delivery, team management, efficiency, and process improvement. And James was formerly the test manager and scrum master at NCS, working with MOH. And also he was a test lead at Cognizant, working with OCBC. Like some of you, he's also an alumni from NTU, graduated in 2017 with a bachelor's in computer science, business minor. He enjoys playing tennis and mobile gaming in his free time. So if you want to connect with James, you can check out his LinkedIn profile, which I think you all would also have in the slides that I've shared on the main document. Okay, the second speaker we have is Kaishen Yeo. So Kaishen joined TikTok in 2022, very recent. She's now serving as a software test engineer for our Global Live Wallet team. So I think some of you have heard from Omer last week, right? So Kaishen is supporting the wallet team. Formerly, she was a software QA engineer with Shopee Singapore. Kaishen graduated from NTU 2020 with a Bachelor of Engineering in Computer Science, specializing in data science and analytics. So highly analytical girl. So her hobbies are running and rock climbing. If you want to get to know Kaishen better, you can also connect with her on LinkedIn. Okay, and then we have the third speaker, Xiaohan Li. Xiaohan joined TikTok in May 2022 as a quality assurance engineer. She's got a master's from Nanyang Technological University in 2021. All three of them are alumni of NTU. So she joined Huawei in 2016 as a software engineer. So if you want to connect with Xiaohan, you can also check out her LinkedIn profile. So I see some of you have already started using the chat function and Q&A function. We'll get to that later. But just before I start, right, I'm just going to run through very quickly about what we expect, from today's session. So as you're aware, you've had like a relatively tough assignment from the backend series. So not to worry, our testing engineers, they're very kind to our attendees. They told me they do not want to give you any assignment. So it will be delivered in the form of a quiz. So you will also find the link to the quiz on the main document, and then you can start attempting the questions as soon as you finish the class, all right? Okay, so now I'm going to hand over to James to take you on today's session. So welcome, James.
Okay, hello everyone. You can see my screen, right? Okay, so today I'll introduce about this software testing fundamental. And you guys, say for example, those people who are interested in software development or maybe anything related to software, right, in the IT industry, right? All these things that we are going through for today's session, right, is going to be very important because not just the tester need to know, the developers, everyone, those concepts that we're going to use, the terms that we're going to use are things that is very fundamental and will be used across. So it's better for you guys to understand what does it mean. And also like, so you guys, when, going to your career or something like that, okay, what is everyone talking about? Okay, so the first topic that we're going to have is, of course, the introduction. What is software testing? So the next one is we'll go through is what are bugs? So to link what is software testing, we elaborate a bit more to let you know what is actually what we are trying to do. Okay, so after that, right, we'll go into things like the software development lifecycle or in the software testing lifecycle. So this is more like a process to let you guys understand what is the journey of a typical project, how will it be run, and also what you guys will be doing when you're doing as a career in the software testing. Okay. Then we go on to things like software testing concept, where you guys will need to have that mindset to know what is going on, and also to know what to apply or something like that. So that will be introduced by Kaishen. Then after that, also testing phase also will be introduced by Kaishen. Will be like what are the different phase that is going to happen during testing. So the next one is on the different testing techniques, which will go through like how to really conduct the test. So it's more of the execution. Then finally, right, so of course, for you guys to, let's say you're interested in software testing career, so how do you actually ace your interview or ace your career? We're talking about long-term career, few years or something like that, maybe decades, something along your career. So what are actually the skills that is actually needed to be a good tester? So which we find that is quite important. So we'll go on to the first topic, which is what software testing. So for software testing, it's actually to ensure that the application meet the intended expectation and to ensure that the product is shipped to the end user with quality and reliability. So it's not just about just testing, it's also about quality and reliability. So if you look at the job description for most company, right, sometimes they will call like quality assurance, quality engineers or something like that. So you can see they will, or some maybe will call it software tester, software analyst or something like that. Okay. So the next and most important is we need to go through the history of testing. Okay, so actually we won't go through this kind of boring stuff. There's no value in learning all these kind of things. Okay, so next one is what are bugs. So these are the 4 topics that we'll go through. So these are some example of bugs. So you guys look at this screen, right? Can you guys spot how many bugs are there? Maybe we give you like 10 seconds to look at it. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So the answer is here. So the first thing is the company logo. You can see the company logo is not TikTok, it's called TokTok. So definitely it's a defect. So the next one is the username is missing. This one is not so obvious. So for this kind of things, right, usually you have to look at the product specification and the requirement. So specification will mention that the name will be displayed, or there will be some UI diagram, maybe in Figma or something like that. They will show where it should be displayed. And you realize it's missing, it's definitely a defect. So the next one is, okay, so for example, like this case, the selected coin package, I select the 70 coin, it's supposed to be 1.09, but the below is showing as $1. So meaning that the customer purchase actually they get it cheaper and the company actually is losing some money. So this one is even worse. You can see that for here it's 70 coins also, but it's $10 plus, it's almost 10 times. So obviously this should be around 700 coins, but actually it's a logic error, so or a display error or something like that. So it's displaying as something. And then next one you can see is quite obvious. The logo is actually being flipped. So this is also considered as a defect. This is more UI defect, and it's not good for the company image because like it's related to company, the logo is flipped. Okay, so what are the different type of bugs? We have like cockroach, grasshoppers kind of thing. No, I'm kidding. Okay, so we have different kind of bugs. It's like a UI issue. We have logical issue. We have functional error. Later I explain what is all that. So performance issue, security, environment, translation, compatibility issue, video and sound, and of course business compliance, which is quite important. Okay, so the first thing is UI issue. So you can see for this, right, the button actually, if you look at the spec, maybe you realize the button is actually not supposed to display here, but somehow it went to here because some CSS issue or some UI issue. So the name also is supposed to be recharged, but it's showing as recharge. So this is definitely an example of a UI issue. Next one is logical error. So you can see here 700 coins is $10 plus. Then after that, 1,400 coins, which is like 2 times more, is actually half price. So definitely something is wrong, right? So this is a logical error. Okay, so next one is functional error. So for functional error, I can look at this. So the moment once I click on this TikTok button, it should go to the home page, right? But instead of going to the home page, it's actually going to a 404 page. So this is a functional defect, meaning that the whole function is not even working. Okay, so the next one is performance issue. So what is performance? Meaning it's very slow or something like that. So you can look at this case. You see all these things are still loading. The image you see is not even loaded. It's like there's an image button here. So these are performance bugs. So this is not acceptable. Okay, next one is security issue. Security issue, very hard to get an example to show you guys. So basically, what people can do, sometimes people do like penetration tests. You hear about the security test or something, they do vulnerability assessments. So those penetration tests, they try to break the application. They try to put in some script injection. They try to maybe put some file into the server or download some stuff from the server or get some information from the server. So that is security issue. So environment related issue is example, like when I do testing in the project, suppose I'm able to do the test, right? But when I go to the environment, the test environment, it's actually receiving network error, meaning I cannot do anything. So definitely I can check my own internet. If I check my own internet, it's still working, I can Google some stuff, meaning that, definitely it's not my network issue, it's the application issue. So that's an environment related issue. So translation issue for TikTok, we are a global company. We need to make sure that we support multiple language. And it's not acceptable, example, like the language is not being translated at when, for example, for certain languages. So it's like not user-friendly to the user. And actually that user might be a good pool of user that's giving us revenue also, then fail to do so, we are losing revenue from that. So that's the importance of doing such testing. Okay. So there's compatibility issue, meaning like, the software must be able to use on web app, maybe even from using on the web application, you are able to use in maybe Chrome, Mozilla, Opera, or something like that. You use on mobile device, you can use in Android, iOS, iPad, etc. So that is compatibility issue. So next is on video and sound. So, TikTok, we have those videos and those live streams. So the video must make sure it's playable. It's not very laggy. The sound, it must be good quality. It's not like maybe 320 pixel or something like that. The sound quality must be, not muffled. It must be very clear. Yeah, so these are all important things. So business compliance also is very important. So we need to make sure that, the app is based on the local regulatory is comply to it. So every requirement, usually we have like, for example, this requirement is meant for US, this requirement is maybe meant for Singapore. We have to make sure that the app and the functionality is comply to the business. So those kind of things, we need to make sure that it's working also. For example, like under 18 is not able to do maybe a recharge or something like that. Okay, so the next concept is we have this thing called the severity versus priority. So what is severity? Severity is basically the business impact. So in the production context, what is production? Production basically is you go online. What happened in online is called production. This is an important term, you will use it in your career. So severity basically describes the business impact caused by this issue. In the project context, the severity describes the impact of this bug to the testing progress or to the release, meaning we cannot release with this bug, or maybe, in this testing progress, we are getting stuck or something like that. So the next one is priority. Priority basically means how urgent it is, and it has to be fixed. So the severity, we have this project definition. For the thing on the left, right, these are typical use terms for different companies that you guys maybe will go for throughout your career journey. You will see that there are different terms, but usually it's these 4 concepts. So the first one is called P0, it's critical, or we call it a showstopper, meaning that you basically cannot do anything. So that's why it's called a showstopper, the show has stopped. So this is considered the most critical, as to be fixed ASAP. Okay, so this is in the project definition. So the next one is major, meaning that it's very important functionality. We cannot allow this to go online, meaning this project the only way for this project to go online is this thing has to be fixed. Okay, so P2 is considered a minor, something that we feel that even release is just maybe some small little issue that might affect the user experience, but it's still acceptable because we need to balance between the time of release versus like the quality also. So that also depends on the whole stakeholder so-called balance of that their priority, whether they want to go for the time or they want to go for like the quality. Okay, so the next one is enhancement, just basically things that we find that where we test, it's not really that user-friendly, maybe it can be improved in the future, then or something like that. So that is considered a P3, a less priority. So for production, right, it's very simple. Basically, the severity is based on the amount of loss cost, or maybe the impact to number of users. So these are very straightforward for production. Okay, so priority is the urgency. So usually they have 3 types of priority, or maybe 4. So one is high, you have to fix it ASAP, ASAP. Then after that, medium, you have to fix within the service level agreement, later I explain. Next one is low, means it's not urgent, then you can just fix it at appropriate time. Okay, so we have 2 kind of cases. One is a normal case and another one is a special case. So the first case, right, is a high severity and high priority. So for example, like I'm a user, I purchased 100 coins, right? But the system so nice, it give me 1,000 coins. So that is definitely a very severe and a high priority issue. The company is making a lot of loss. So maybe I send a gift to the host. The host can actually use the money, they can withdraw from their wallet as like from their support from the user, but I can send it infinite. So the host is like getting money infinite. So the company is actually paying for this host free of charge. So that is a very big company loss. So you can see this is considered as a high severity and high priority. So the next one is the low severity and low priority. So basically we have like a grammar error, which is like not very obvious. Emphasize is not obvious. Like if it's obvious, it's still considered like medium priority. Okay, so the button size is slightly smaller than the UI design. So the UI maybe is around maybe let's say a few cm, but actually it turned out like just a bit smaller. Then usually for this kind of thing, we'll look at maybe if it's not usable. When the user find that when for example you're doing testing, you click on it, it's also very hard to click. Definitely the user is going to face a problem. So next one is a special case. It's like high priority and low severity. So first one, just now we gave an example, is like, you see this one, Talk. The company is called TikTok, but shown as Talk, meaning that this is very obvious to all the users and it's displayed at a very prominent location. It'll be a laughing joke if it's this thing happened, right? So the next one is the localized word translate wrong meaning. So sometimes we deal with a lot of language. So certain language might, when it's translated to maybe Vietnamese, the meaning is a bit different. So, and actually it let the user misunderstood the functionality. So that is a problem, okay? So the next one is high severity but low priority. So meaning that it's very important, but the thing is there's no rush to fix it. Okay, why no rush? Because for example, like this case, right? It's a report generation function that is very rarely used, emphasize on the rarely used. And it's very slow. And for an internal platform, meaning it's used by internal user. And there's only a few people using it. So it's very few people using it and very rarely used. So there is a bit of leeway, of time for the developer to go and fix it. That's not a very high priority, despite it's a high severity issue. And maybe the user will find that, hey, I use it once in a blue moon, it's very slow, but I'm okay with it. Okay. So the next one is defect service level agreement. Basically, it's state for each organization. The below one is more like a benchmark or typical used by most organizations. Different organizations, they will set their SLA level. That will depend on the company you go to or something like that. So, okay, so for this SLA, it's basically how fast the developer has to fix and how fast the tester has to verify, and of course, like being released to the online or something, or maybe released to the test environment. So this is to define the organization project standard when during the time taken for the defect to be fixed and verified released from the time of discovery. Okay, so maybe we go back to here. So you can see for P0, right, and high, it will be AZ. So you can see there's a diagonal concept. So P1, high, will be 2 days, same for medium and P0. So you can see it's diagonal, and last one you can see is 30 days. So for the P3 and the low priority, you can slowly take your time. Okay, so how do you report a bug? So after you find a bug, right, you have to log it in the organization or the project defect management system. So what is the defect management system? So some company, they are very cost saving. They don't have the money to invest in tools. So they might use things like, Microsoft Excel. It's very primitive, inefficient, but, it saves the project or the organization money. Okay, so the next one is cost of the shell products. That's COTS. So one is called Jira. It's a very popular tool. There's HPALM, Bugzilla, etc. So these tools are commonly used across most organizations. So you have company internal tools. So for example, TikTok, we are a big product company. We have the resource to invest on our own internal tools. Okay, so how do you raise a good issue ticket? So it's very important, and I think often I see in a lot of testers, right? This is very important, but always underrated. It's a good summary. So because when you look at a ticket, right, you don't go look into the details. You will just look at the summary in the defect tool management system. So when you have a good summary, one look at it, I know what's happening and I know what is going on. So it's very good for the example you're doing test management. You just scan through everything. Okay, I know what's the project state. So what is a good written thing? How come there's a gap? Okay, so the template is for example, the environment feature. There's a feature name. Then I have a platform, the country, the page, module, submodule, what action does user perform, and also how the system react and what is being expected. So for this case, this is what I consider as a good example. So you see the environment is example, system integration test environment. There's a new text form. It's basically this feature name. It's happening in Android. It's happening for Singapore. In the text creation page, the name field, so it's a field. So you fulfill this module and submodule. Then after that, you explain the behavior. When user key in the name of more than 10 characters, system throw validation error instead of more than 50 characters, meaning the system should throw an error only when it's more than 50, but somehow the developer might write the logic wrongly, you put as 10. So that actually caused the issue to happen. So for the description, right, we can straight away tell, okay, this is a P1 severity. We cannot release this because nobody's name is that short. Also, we have that medium priority. So it has to be fixed with a certain speed. Okay, so the next one is a bad example. So the same defect, but if written by different testers. So some testers, they are not very good at describing. So what they write is the text form encounter error. So to us, right, when we look at this, what implied basically is P0, severity, high priority. Basically, the text form is not usable. So we look at it, well, everything is, high priority, then it's not good for the developer because developer don't know which one to prioritize and which one to fix first. And after that, when we look at it, after we realize, hey, this is a simple issue. This is just a simple change or something like that. So this is why, we avoid writing in this state because it actually is very inefficient. Okay, so what to fill? So for a defect list, when you raise a bug, usually you want to write the issue summary as explained earlier. There's an issue type, whether it's a bug or clarification. There's a team or which module, which team is being assigned or which module is it related to. Then the platform that's impact, is it just Android or is maybe, Android, iOS also, or maybe even web application. Then what's the bug category? Later explain what is a bug category. Then after that, we have severity and priority. Then after that, we have bug category, sorry, not later, just now I already explained what's a bug category. Okay, so the issue and description, then also environment found. Then after that, we have attachment. Okay, then we have a discovery phase. So who to assign when we, who to assign? So the first identity, right, is to find this issue is a business or technical problem, which is the most important. You don't really ask the wrong problem to the wrong people. For example, ask a tech problem to the business people, they will give me a wrong reply. And after that, the issue might happen to online. And you cannot really blame the person because the person is not an expert in this field. So for business related issue, you always ask the product manager owner or product owner, or you ask the business analyst or user manager. This one is depending on organization, which role do you have, okay? So the next one is you ask for technical related issue, you ask the software architect or manager, or maybe the development lead, the developers, DB admin, infra manager. DB admin, infra is DB usually ask for regarding database issue. Infra is more of like those network issue or like maybe some deployment system unstable or something, not enough memory. Okay, so next one is on the design or localization issue. So the UI, maybe you realize that the defect actually is not caused by developer because in the requirement document, the UI design is a bit strange. So that is why you need to report to this UI UX designer, ask them maybe they can look at it and optimize it because things might not be up to what they think in the beginning. Okay, so localization team is more for like if let's say for example TikTok is a global company, we support multiple language. So there's some language issue, we'll ask the localization team to take care. Okay, so how to follow up? So usually when you log a ticket, right, you don't just message the person with issue, you just don't just message the person and log a ticket and just don't communicate. So you're supposed to really just go and message the person and also tell them, okay, this is the issue, how can we fix this? Because you realize as a software tester, right, most of your time in software testing is not the test execution speed that is causing the delay, usually the defects that is causing the delay. The time taken to fix the defect can be very long. So it's very important that you can speed this part because this part is always the bottleneck. So the next one is, right, you have to set up a defect triage meeting. What is defect triage meeting? Basically, the stakeholder for every team, right, they will be in this meeting and they will send one representative. They will also acknowledge, they will prioritize and also discuss about the issue. Okay, so this is a typical bug state diagram. In every organization, you will see that it actually varies for the different state. Like all the state, right, you might have different statuses. but the typical structure of a bug concept, right, is always the same. So you have an open ticket when somebody raises an issue, you gauge whether it's a valid issue. If it's not valid, then of course you close it because you maybe understand wrongly or something like that. Okay, so if you realize that it's a valid issue, then next thing is it severe or is it not high priority? So it's not severe and high priority. What happened? You can put it as fixed in future, meaning we can do it later because it's not very important. Okay, so next, right, is let's say it's severe and also high priority. So we put as in progress. So after that, once it's in progress, developer will pick the defect up, they will put as fixed. So once it's fixed, right, the tester will go and retest it. So if it's not fixed, retest it, they realize, actually still broken. Why the developer put as fixed? So it will be reopened. Then after that, we'll put as go back to in progress again. Okay, so developer will fix. Then after that, it will repeat this whole cycle until when to close. But of course, as a developer, it's not good to have too much reopen because reopen is actually considered a taboo, meaning that the number of count reopen will be put into the statistics. The developer manager will actually, lecture the developer why is there so much reopen? Why is it so careless or something like that? Okay, so the next topic is SDLC and STLC. But meanwhile, we can look at some of the question. Okay, there are different types of test engineer. One is manual, one is using code. How can code test be able to identify videos and graphic in case of TikTok logo becoming top? Okay, so the code test, I believe you're talking about things like automation testing, right? Automation testing, you can actually use some image recognition for that case because that thing is an image. So if you compare the image, right, then after that, you can actually find out that, okay, yeah, the image is not matching, so it's a defect. Or if it's text, right, then you can just use some text comparison. So that is how you actually solve the problem. Yeah. Then maybe I answer one more. What are the difference between video and sound bug and performance bug? Video and sound is purely based on because we do those videos, right? Okay, so video is purely based on those like animation issue or something like that. It's not really performance because certain things like there might be some the voice might not be that clear or something. That's not performance issue. That is a sound issue. Okay. Yeah, so we go on to the lecture later. We'll answer all the questions. Yeah, okay, because we are not really have a lot of time. How do I? Okay, so what is software development lifecycle? This one is very important. I believe a lot of lecturers mentioned it, but I think it's very important to know this concept. Later explain in a more advanced level of what is being trending in the industry. Okay, so the first one is to gather the requirement. Then the next step is you can see, okay, why gather requirement is very important because you need to know why is it happening. So you need to analyze what is actually needed before you start designing. If you understand wrongly, right, then you will go haywire. You will just go not what the product wants. Okay, so the next one is after that you design the solution. So you design the user journey, you design the solution, the UI mockup, etc. So once all this thing is done, right, you start with the development. Then after that, you do with software testing. So you test whether make sure everything is expected with quality and reliability. So next, after finish test, right, you can go for deployment. You can release to the market for the user. Then the last one is the maintenance, meaning like after you finish already, right? So you need to make sure that the software continue to run. Okay, it's not like after you finish the project, it run for 1-2 weeks and it spoil. So that is not acceptable. So that's what we call maintenance. Okay, so you realize this step is like how you eat. So when you eat, you need to pick up a spoon, scoop the rice, slowly put in your mouth, chew it, swallow it. So all these steps, right, cannot be skipped. If you skip, it's called cutting corners. Later I'll explain what will happen. Okay, so for software testing lifecycle, right, it's mainly happening in the testing phase, but there's some prep work also. So it's make up of 6 steps. First thing is the requirement gathering. Same thing is realize it's same as SDLC. So you really need to understand the context, always understand the background, everything, so you know what's going on, what is actually required. Then you know how to do it. So after that, you plan on how to test it. So how you know how to test, you need to know what is in scope, what can be tested, also what needs to be tested, what is not really important, and also how to test it, and what are the resources required. Resources refer to maybe tools and also the human manpower, what kind of tester you need. Experienced one or maybe junior is also okay, depend on the complexity of the project. So the tools is required, and also what are the risks, what kind of problem that you are going to encounter the project, how to actually mitigate the risk, how to prevent it from happening. So what's the timeline, and also what are the standards, like entry criteria and exit criteria. Okay. So the third step is the test scenario. You design the test scenario, design the test case with clear test objective defined. So it's very important to have clear test objective, because if not, you won't be knowing what you're testing. So the next one is to prepare the necessary data, and also that is required to run the test case while the developer is still developing. Then make sure the test environment is ready for testing when it's nearer to the testing phase. So the next and most important step is this one. So when you execute the test, then you need to make sure that all your test cases are covered and passed. The defect will be raised, handled, and closed during the testing phase. So there's also another concept called the condition sign-off, meaning that there are still some open tickets, but stakeholders feel that this issue can be solved at a later stage. That means after you release, you can still fix it along the way and release another one. Because those issue is not very prominent, it's not that important. Okay, so the test closure, of course, is like a end to close everything, closing ceremony, make sure that everything passed, like no open issue, the tester can sign off saying that this product is good, we can go on. Okay, so this one is quite important. You can look at those job description around on LinkedIn or any job street or something like that. You realize people talk about the agile model. Okay, so there's traditional model and agile. So it doesn't mean that each model is better. Which model is better? Actually, is more of each model has own advantage. But of course, there are certain ways to do things is more being efficient. Okay, so the first one is waterfall model. So another one is waterfall, right? Basically, is when you're doing something, you're trying to do things as a whole. Okay, and you go by step by step. So the next one is Kanban. Kanban is where it's like a manufacturing process. This concept actually comes from manufacturing. So they do this thing called the Kanban board. You can see there's to do, in progress, testing, and done. So usually different organizations, they have different Kanban with status. So every feature they go in, they'll go to each stage. So some will be in progress, some will be testing, some will be done, some will be still in to do, or some will be still like still planning or something like that. So the next one, which is quite popular nowadays, is called Agile Scrum. Okay, so Agile Scrum, you have things like user story, product backlog, sprint backlog, etc. Okay, so the SDLC model just now explained, right, is to make sure that the whole project, right, is done using a Big Bang method. Okay, so the SDLC is carried out sequentially. So what's the difference here? You can see here, right, the requirement design, I must complete all the requirements. Okay, just imagine this thing, right, there's 100 pieces of, I can either do it as a whole or do it in 100 small little pieces, but I decided to go as a whole. So this whole thing all the 100 things must go through the requirement, then all must go through design together, implementation, verification, and maintenance. It must go through one shot together as a whole. That is waterfall. Okay, so the next one right here, right, is agile. Agile is where I can chop this small little present, right, into smaller present. So after that, these are different features. So some feature I can execute simultaneously, and some has to do it sequentially. So why it has to do it sequentially is because, right, there are dependency. If I don't do this thing, I cannot do the other one. So that is why there are also some limitation to agile also. Okay, but all these things does not break the SDLC concept. You still need to follow the whole SDLC journey. Okay, so some of the typical SDLC model here is like Kanban. So just like I explained, these are all things like a manufacturing process. These are all based on this thing. We have backlog to do, like etc., something like that. Okay, so the next one is Scrum. So Agile Scrum, right, is example, I have one whole list. I plan, this list is a living document. Living document means that, I can keep adding stuff along the way. I think of a new idea, just put inside the backlog. It's like a to-do list, I have a lot of things to do. So after I put into the to-do list, right, I have to prioritize it, which one I feel is very important at that point of time. So after that, every sprint, which is determined by the organization level, whether it's 2 weeks, 1 month, or 1 week, or etc., then they will say that, okay, for this month, we will do maybe, for example, this set of features. So it will go from the product backlog to the sprint backlog. And after that, it has to complete the duration with example like 1 month. Okay, so they'll go for sprint planning. They will say that, okay, these are things that we're going to take up. Then after that, you'll go into the product backlog, sprint backlog. Then after that, we'll do the daily scrum where everyone will check in, say that, what they do today, what they, what they do yesterday, what they do today, any issue they are facing. Then after that, they will do the development. Then after that, they will do testing, or etc. Then after that, the whole thing will continue until they will do a showcase at the end or something like that. Okay, so now before we go for time or break, let's answer a few questions. Motomi, how much time I have?
Okay, now we have, we are at 7:13. So I think we can go into the Q&A.
Okay.
Mm.
Okay, so but the program can never be 100% bug free. In that case, how do you guys check for bugs in that? There are bound to be some bug that you will not find so easy. In that case, how do you handle this kind of bugs? Or do you wait for user to report? Okay, yes, so you cannot really test. Okay, so same for me, I explain in a different point of view. So same for testing a program, right? You cannot do what we call exhaustive testing. So meaning we test every single thing. That's impossible because why? We have a project timeline. So we need to make sure that we meet the timeline also, because if we didn't meet the timeline, for example, for a product company, we release the product later than the competitor have an advantage. So there is need to be some balance. Okay, so how do we actually, then now, right, we cannot test 100%, right? So how we make sure that there's no bugs? So there's this concept called the risk-based testing, where we take the risk. So how we take the risk, we need to prioritize what is the most important for this functionality. What kind of things cannot be broken? Example, like all the what we call the P0 case, the priority 0 cases. Those are all critical cases for this functionality. We cannot afford this functionality to have issue for all these things. So this is roughly based on that priority. Then you guys can prioritize what has to be tested. Then after that, those things that going to bound to happen, right? Like I say, those bugs that bound to happen, right? Those are going to be very small issue, which is not very, it won't affect the user that much. But of course, there are also different kind of bugs, like environment related issue. Those are a bit more tricky. Like example, suddenly the server is down. That is actually not a bug. I see that's more like an infra issue. Okay, so I hope that answered your question. Do test engineer do the code change or open Jira ticket if a bug is being noticed? Okay, so the fixing of the bug, right, is a developer job, because they code they do the coding. Then once there's a bug, they have to fix the issue. So for a test engineer, right, we don't do the code change. We just going to report the issue. But just now I mentioned, right, most of the problem that happen, right, is during the testing phase that the duration of testing phase is going to be very long. It's because of the bugs that are actually happening during the testing phase, because it takes very long to fix it. So it's best that you can play with the application more. You can understand, something can do reverse engineering. You can roughly know, okay, this is roughly what happened, how the developer actually code from there. Or maybe you can do some code after, they can look at the code and see how it happened, check the DB or something like that, check the logs, then realize, oh, okay, it's because of that. So you can actually help the developer say, hey, you see, this is how it happened. So please help to fix, and you can actually help to save the developer time. But of course, this one is to balance, because sometimes you are being rushed by the project timeline. So the developer has to do more investigation. Okay. Latency part of QA checking tool for user experience. Usually if you're doing just purely functional testing, that depends on organization. Some organization, they make the QA like more like a full stack, meaning you need to check most of the stuff. But sometimes some companies, right, they operate in a way that the QA is more doing purely functional testing. Okay, so after that, right, okay, so the QA is just doing functional testing. So functional testing, you don't really care about the performance, but does not mean, right? Example, I click about, it's supposed to download a file. I click on this file, it's taking like 1 hour to download for maybe just 10 records. I think that's not reasonable, right? So that is confirm a problem. So that is going to be captured in functional testing. What we talk about the latency is maybe like, instead maybe it's taking 3 seconds to download, but actually the acceptable is supposed to be 1 second. Yeah, so that is more of that. So that's called performance testing. So that you have those performance testing tool, which we'll cover in our next lecture. Okay. So how a production bug discovery, right? How a production bug discovery process like TikTok and key responsibility at each stage. Okay, so this one is quite hard to describe, in a short in this Q&A, right? So what happened is so basically that's how we discover a bug, right? Worst case, of course, is a user reported. You don't want that to happen. So what we can have is we have those alarm and monitoring system. So you can look at the APIs, the way they are being triggered. So if let's say there's a drop in the SLA, meaning like the API, it's not 100% passed, there's some error in that. So we notice that the error rate might be increasing. So once a percentage increase, right, meaning there's a production bug, very high chance. So then we will go into investigation straight away. We have some metrics to tell, okay, maybe this one happened maybe in Singapore. Then we'll look at, based on Singapore, this function, is it still working in Singapore or something like that? So this is roughly how we find. After we find already, we have to go investigate. Once we're able to reproduce it, we will send the engineer team. The engineer team will go and fix it ASAP. Then once they do the fix, right, we have to quickly test it. So test it ready, it's okay, we will roll out straight away. So that is how that whole process is being happen. So if that case, it happened in the middle of night, then yeah, it's not that well for everyone. Okay, so how raising an issue in Jira works? Does it go through the backlog, or Scrum Master decide if dev should work on it or middle sprint or wait till the next sprint? Okay, so if you in testing phase, right, if you raise an issue, definitely it's a bug. So you have to fix it ASAP based on the priority. But some organization, they might have this concept. It's not Scrum Master decide, it's the product owner decide. So the product owner will come in and say that, okay, this one, yeah, this is very important. This one, you better fix it, or something like that. So because the product owner is the owner of the business aspect, so he or she is going to make that decision making rather than Scrum Master. Scrum Master is just a facilitator role, so he should not be deciding these kind of things. Okay. What is text form? Text form. No, the context of that ticket is text form is the feature name. It's not the yeah, it's not really why is a high priority. If if the feature is about creating text form and the create button is not working, that's a P0 issue. So that is just a very easy example. Just like example, I have a customer creation screen, maybe a registration screen, and the register button is not working. Now that's definitely a P0 issue. Okay. Are there any SLA for defects? Yes, just now that table there with the ASAP or 30 days, that is the SLA. So you can look at the slide on that. Okay. So meanwhile, I think should we go for that 5-10 minute break? So Motomi, how much time we have for
Yeah, I think because today's session is a bit shorter, so is everyone okay with a 5 minutes break today? If yes, we raise your hand. 5 minutes. Can I get a raise of hands if you're okay with that? Okay, fantastic. So we'll do a 5 minutes. We come back here at 7:25, and then James will still support you with all the questions you have raised here, right, James?
Yeah, I can maybe type
Okay,
it. I think
yeah.
will be
So not to
easier.
worry, we come in 5. Okay, thank you.
Motomi, should I start now?
Yes, 1 second.
Okay.
Okay, is everyone back? Can I see a raise of hand? You are back, right? Still around? Okay. So we'll hand it over to Kai-Shen to take over from now. Yeah, thank you.
Thanks, Motomi. Yeah, so hi everyone, welcome back from your 5 minutes break. So in this next part, I'll be covering section 4 on software testing concepts and also section 5 on testing phases. So for a summarized breakdown on what we will be understanding more of in section 4, it would be more towards the software testing concepts that we generally use while testing. And specifically, they are shift-left testing, continuous testing, and also context-driven testing. So firstly, for shift-left approach to testing, it is very frequently used in the tech industry, and it involves introducing testing into the earlier stages of software development so that we can detect the defects much earlier. So with shift-left, we hope to gain a higher quality product with a higher quality code base, since there would be fewer patches and code fixes in our code base. And it also lowers the chances of having the product overshoot its estimated timeline. So with that, we can achieve a higher customer satisfaction rate due to the better stability in our code. And the feature can also be delivered within the budget. So with this, the main goal here is actually to allow us to gather critical bugs earlier so that they will not turn into online defects if they had been found after deployment and the release of a feature. So with that, it would often require code patching in the production environment. And if you look at the diagram on the bottom right of this slide, it shows the effort expenditure for a typical software development process, which uses the traditional sequential model, where testing happens more towards the end of the timeline of the project. So with that, developers and product owners often found problems that weren't covered by tests, and it's very costly and time consuming, and not to mention very late at this stage to fix such a bug. And in a worst case scenario, there's even the possibility of developers having to redesign the entire application because of that bug, which actually raised some concerns about the designs for the current tech architecture. But if let's say you look at the diagram on the top right of this slide, you can tell that the testing effort is high and also very intentionally placed in the earlier stages of the SDLC. So the idea of shift left is actually originated to engage the testing team as early as possible in the SDLC process. So in pushing for shift left, we could adopt test-driven development, requirement analysis, as well as test automation. So yeah, this is shift-left testing. And then moving on, we have another concept on continuous testing, which is seen in the practice of CI/CD, which also stands for continuous integration and continuous delivery. So with CI/CD, it pretty much automates most, if not all, of the manual human intervention that is traditionally needed for us to get the new code from a commit into production. So with this, it actually encompasses the build, the test, as well as deploy phases, and also the infrastructure provisioning. So with CI/CD pipeline, everything becomes more dynamic because the development team can make changes to code more easily, and they can then be automatically tested and pushed out for delivery and deployment. So it's very swift over here, and it minimizes a lot of downtime and allow for our code release to happen much faster. And because of this swiftness, there is that need for continuous testing, where our tests are typically performed automatically, with each code triggering a series of tests that ensures that our application continues to work as expected. So this helps us to identify problems early and also prevent them from being very difficult and also costly to fix later on. And it's also very valuable in terms of feedback to our developers because it conveys code quality and also helps them to identify and address potential issues before they are actually released into production. So with this CI/CD pipeline, it allows us to make continuous improvement much easily, in a sense where it prompts us to think and question more about how we could make like each processes much better if we were to do the same thing again. And with that, the processes or even tools that are created from this whole entire chain of thought process, it helps us to increase the testability of the software and also our testing efficiency overall. And yes, that's continuous testing. So finally, we have the context-driven testing, which involves testing based on the context of the project, then performing testing in a going by the books or like a fixed notion of best kind of way. So with context-driven testing, there's actually no single best practice that applies to all cases. And in this case, testers will choose their test techniques, deliverables, documentation, and also objectives by looking more into the details of the specific situation. So this is more of like a project appropriate application kind of skills and judgment, whereby testing is more customized and also more specific and tailored to a project, rather than the application and usage of the same old conventional methodology across all of the projects. And it generally involves testers being more skeptical and also more adaptable, because we would need to observe and analyze more thoroughly. And doing so actually helps us to open our minds up to new and different ideas. And it's also not about creating as few tests as possible, but rather as many and also as challenging tests as possible, because it's important for us to adapt to changing contexts and requirements. And context-driven testing is also very diversified and heuristic, since it doesn't follow any processes blindly. So this helps us to discover and also learn more about the best approaches to follow depending on the situation at hand. And generally, I would say that context-driven testing is used to attain a few certain objectives, like when we are trying to clarify the purpose of the project, or when we are trying to supervise testing challenges, planning challenges, or even like just evaluating the project and analyzing the risk that's associated with the product, or even like besides just setting up the usual logistics and planning the test strategy. So yes, that's the three parts on software testing concept. And next we'll move on to section 5, where I will introduce the 4 main testing phases. And so generally, before any software is developed and released, it will undergo a series of tests to ensure its accuracy and functionality. And the series of tests would mainly include unit tests, integration tests, system tests, and also UAT. And so we start off with unit tests, which forms the basis and the foundation on which all the other tests are built on. So unit test is actually a process where minor functional parts of the software are tested individually to check that each individual components are functional, are accurate, and also efficient. So the unit in unit test actually refers to the smallest piece of code that is logically isolated in a system. And over here, they could be a usage procedure or a unique function or a module in a program. So unit test is actually done in the early stage of development. So usually done by developers, where the unit test that's done by them validates that each unit of the software works as intended and also meets the requirement that is given by the product manager. So doing unit tests actually helps the developer to deepen their understanding of the code's functionality, which also helps to facilitate code refinement and also refactoring where code change is required, such that any code change that is made by them do not break existing functionalities. So doing so actually helps in terms of faster development and also higher efficiency. And so that's unit test, and it forms the basis of all the other tests. And then moving on, we have integration tests, where all the modules are actually logically integrated. So in integration tests, we verify how the disparate elements work together, and we evaluate the system's compliance with respect to the functional requirements. And it's actually a very crucial phase because it ensures like seamless interactions between the various code components and also their functionalities. And also like we can understand better as to how they operate as a single entity. So with this, it actually helps us to expose any kind of defects, bugs, or errors in terms of the interaction between the software modules, while also emphasizing on the data communication between the various modules as we try to understand the logic that is implemented in the code, and also to check and verify if like the rendered values actually follows the requirements of the test plan. So moving on, we have the system test, which is even much higher level, whereby we test the complete and fully integrated feature to verify the overall functionality and the performance of a system. So we do this test to verify that the entire system actually meets the specified requirements in a higher level way, and to check that it's suitable for delivery to the end users. So the tests here usually comprise of like end-to-end testing to validate for the system's compliance and also architecture with the client's functional, technical, and also business requirements. And tests can be functional and non-functional in this aspect because it mainly serves to detect irregularities between the integrated units and also defects in the whole system. And so lastly, we come to the last part where we have the UAT, which is also known as the user acceptance test. So it can also be commonly known as beta testing or end user testing. So UAT usually assesses the efficiency of the entire software in providing the intended solutions to the target audience. And it also checks if the system can support the day-to-day business user scenarios, and also ensure that the system is sufficient and correct for business usage. So with UAT, the aim is actually to develop a more user-centric product that caters for better customer experience with better and enhanced product usability. And so that concludes the 4 main testing phases. But beyond the software testing lifecycle, we also have processes like gray release, A/B experiments, monitoring, and alarms that go hand in hand as we deploy and also release the feature for global users to enjoy. So with gray release and A/B experiments, we seek to do online traffic control and also to split the users' traffic into different experimental groups. So basically, if we try to understand what a A/B experiment is, it is that user experience research methodology where we try to analyze and also understand how a feature performs against like a controlled baseline that we had set. So it's a way for us to compare 2 different versions of a feature and to figure out which one performs better so that we can apply the one that is performing better. So for instance, there could be an original logic flow and also an experiment A, B, C, which are evenly split at 25% of the incoming traffic. So with that, subsequently, as we try to release our feature, we monitor for online issues and also events by observing the traffic rates for the respective APIs that we have triggered and also their success rate. So there is an alarm system that we implement that is a configured rule-based automation system that would alert respective developers and testers that are involved if there is drastic statistical differences during our issue tracking. So with this, in this case, we would need to prepare for code patching to fix and restore the system state if like such incidents occur. Yes, so that is section 5, and I think with that I've come to the end of section 5, and we can now move on to section 6, and I'll pass the time to Xiaohan, who will introduce more about it.
All right, thank you, Kaishan. Did you realize that our test engineers have very good time management? They had to prompt me to give a break, they prompt me to start, right? All right, again, thank you, Kaishan, for your time. So Kaishan is staying like late in the office tonight, even though she's on leave tomorrow. So yeah, I would like you all to maybe raise some appreciation for her as well. Thank you, Kaishan.
Thanks, Notomi, and thanks everyone for attending. And also thanks to the other two presenters, Xiaohan and James.
Thank you. Enjoy your trip.
Thanks.
Okay, hello everyone. I'm Xiaohan. Now let me move on to the next part. So first of all, I will introduce the different testing technique. So for this part, I will give you a basic understanding about what's black box testing, white box testing, and as well as gray box testing. And I will also show some by using some examples to let you much more detail about this part. Hold on. So now let me introduce some basic description about this part. So first of all will be the black box testing. So when we do the black box testing, we don't totally know what is inside and what are the right for that code. So what we only know is that we will know what we want to get for the basic scenario. For example, we will at least know what we will want for this feature and what we will want for in this scenario. But the issue is that actually there may be some cases that, for example, RD will write some code we don't have. For example, they actually have this logic like A plus D equals to E, but we don't have because we don't test it because we don't know RD actually write something related to it. So that will be a feel of about the black box testing. But what will be white box testing? White box testing is more like you know everything in this system because you know what will actually write from the developer side. They have written and we will go through every single path. But this issue is that maybe in this case we will pay more attention to the for example, each path, every single path or every single branch, but we may forget about the overall end-to-end scenario. So that will be the issue about the white box testing. Even though we will know everything, but we may forget to consider about something. So next part will be the gray box testing. So gray box testing is more like to combine the both white box testing and as well as the gray box testing. But it will take so much time for the testers because we also need to get a better out and deeper understanding of the overall system. We need to know the design architecture, the design pattern, but we also need to know about the business and the technical solutions. But like why we have these technical solutions, why we have these design solutions. So in this way, when we do the gray box testing, we need to know something related to the developer side, and we also need to know from the product side. So we will have the overall technique for both what the black box test have and what the white box have. So now I will give you by using some simple examples to introduce what black box testing technique we have and what white box testing will have. So first of all, it will be the boundary value analysis. Okay, let's say you are testing a simple e-commerce app that allows users to purchase products online. For this requirement, this website will allow users to buy the order amount. The minimum amount will be $10 and the maximum amount will be $1,000. So let's see what we will have the test cases by using boundary analysis. So for example, as we already know, between the 10 and 1,000, what we need to pay attention is to like the minimum boundary and the maximum boundary. So we have to test the 10 and 1,000. But in some cases, like near the boundary, there will maybe some cases developers that they forgot to like the equal and lower than the equal. So we may also need to pay attention for the value which is below the minimum amount and above the maximum amount. That's why we have the test case 3 and test case 4. Then let's see. But it's when we also need to test that it's in the boundary. So, but we also need to pay attention for the value that will be near the boundary. So that's why we will have the test case 7 and the test case 8, because we need to test the 10.0.1 and the 999.99. So let's see, it's in the boundary value analysis, we will have these similar test cases because that's also needed value we need to cover during we test this program. Okay, let's move on to the equivalence class. So let me see. Because I will use this as an example because this requirement is like that we need to test the numbers between -100 and 100. Then and then the system also allow us to division by 0 is not allowed here. So let's see, by using equivalence class, what will we do here? In this example, because we have the input domain into invalid and the valid equivalence class based on the given requirement. So let us think about it. We need to test the positive numbers and the negative numbers. That's two equivalence class. And then we also need to think about the integers and the decimals. That's another one. And we also need to think the combination of both positive and the negative numbers, and need also to pay attention to the numbers between and the other side, the -100 and 100. So by using equivalence class, we will have some test cases like this. So the first of all is that we need to test the two valid numbers, and one is positive and another one is negative. And then we also need to test both positive and both negative. So let's see the 8 test cases. So in this, by using the equivalence class, we will almost test all possibilities of this system we will have. So this is the what boundary what equivalence class told us to do. So it will be pretty useful because we won't miss something during our test. Okay, now let's move on to the flowcharts. So by using flowcharts, we can create a visual representation of the program's logic and identify the possibilities test cases based on the different passes of the program. So it will help us to have a visual view about this program. So we will know from flow to flow to know what will happen during this. So let me give an example here. So it will also be a pretty simple program. It will take 2 numbers as the input and performs one of 4 possibilities to do the operation like addition, subtraction, multiplication, and division. So based on the user's choice, we will have 4 choices here. And then it will have like the user from the start to the end and the start from the input and then to do the choice, and after that we will get the output. So we will use this flowchart to help us to have the test cases quickly. So let's see what we have. So this is the result of the test result here. It's also pretty simple, but what we can find is that we will find during different passes of this program, we can ensure the program is functioning properly and handling the input correctly. So we will need to handle the both invalid input and the both valid input here. So when we will have a more systematic scenario in this one. Okay. Now let's see what will another one is that the state diagram. Let's see an example here. So it will be an exchange system, which is to exchange SGD to the USD dollars. So after that, the specific requirement will be like we will have the specific exchange rate, and we also have the minimum and the maximum amount to be exchanged. And this application should also display an error message if the user enters an invalid command. So after that, we will use the state diagrams to do the analysis, and it will start from the start. And after that, the user will be enter the amount of the value, and after that to validate it. Then we will have the different result according to the specific exchange rate, and we will also have the error message if it's an invalid amount. So let's see what it will work by the statement. So the test cases will be a little bit similar to the test cases like the boundary values, but what we have and what we will have by the help of the state diagrams here is that we will analyze this in different state, what statement we need to cover, and we won't miss anything in this flow. It will be the value of this statement diagrams. Okay, let's see the decision tables. Okay, let me show you the requirement. You can see it will be a pretty simple login system for web application, and the specific requirement will show as below. So you can see we will have ask the user to master enter the valid email address and password, and we'll also have the limitation for the email address and the password because they need to be some specific format. And we'll also have different error messages once the user input the invalid ones. So we will also have different error messages here. So let's see what will decision tables works. So first of all, there is two input in this system. One is email address and another one will be the password. So for both email address, we will have valid and invalid. But to be honest, for the different invalid email address, it will have different formats. So we will just pick some specific ones to do the test, but won't cover all of them. And for the password, as we also have the limitation for it, so we will also have the valid one and invalid one. Then we will do the combination for the email address and the password. So we will have 4 different output action. So at least by covering the different input combinations, we can ensure the login system is correctly handling and is functioning correctly. So this is the decision tables help us. Maybe this one is not so good an example, but it will just give you a basic understanding about what will decision tables work here. Okay, then this is the specific test cases because you can see here is that it will cover both valid, invalid, and different scenarios for both email address and the password. Okay, let's move on to the array testing. So this one is also a little bit similar for the last example, but this one is that this time this platform is allows to create new accounts rather than to do the login. So you can see here is that the requirement already told us that we need a unique username and a valid email address and a strong password to create an account. So we will also have the different limitation for the username, email address, as well as the password. So we will covering by using the matrix with we will cover almost all combinations of the input values because we will use each row in the matrix to represent a unique test case. And for example, we will have the username. Let me give you an example here. So we will have the username, email address, password, and the expected result columns here. So this is how it works. But to be honest, as this requirement also told us the username should be unique. So we also need to add another test case here, is that to verify if duplicated username can be created in this system. So this is that we will have a better understand about and have the test case quickly by using this array to do the analysis here, and won't have some no use or no meaningful test cases, but we will also have some edge cases here in this scenario. Okay, so you can see it will be pretty efficient and effective for us during our daily work to do a test. Okay, let me so. Okay, that's all for the black box testing. Now let's move on to the white box testing technique part. So first of all, as Kai-Xuan already mentioned before, it's the unit test. So the unit usually will be done by the developer side, because usually the unit test need to be written immediately after the code developer finished. So what will unit test do? Because we need to test the different statement coverage, different branch coverage, and different path coverage here. Unit test will be while the individual units or components of the software application, because it will be tested as in isolation to ensure that the function will be as intended. So let's see what will we get from the from this unit test here. So first of all is that it will be early detection of testing. So let's Kai-Xuan already said we need to find the bugs more earlier, because that will reduce the time to fix and won't waste our time. So as early as the test, bugs can be found. For example, the unit test is in the pretty early stage, because it will be tested immediately after almost the code finished. So it will change the defects of an early stage, but the overall cost of the development will be reduced, as well as the overall quality will improve a lot. So that's for this part. And another one thing is that it will also increase the code quality, because it helps to improve the quality of the code by almost every branch and every unit and every component here, because we have limitation and requirement for the unit test coverage. It's almost should be at least around 95 or plus % of this. So the code coverage will be pretty high, even it's just don't pay attention to the overall system, but at least we covered almost every branch. So it will help the developer to reduce the likelihood of introducing bugs and the errors into the code. And another thing is that it will help us to provide a safety net for making changes to the code, because it allows the developers to modify the code without fear of introducing new bugs, as the test will catch any issues introduced by the changes. Also, because I think it will be found pretty earlier if we have the unit test here, because for example, some crash or some other framework issues can be found by using unit test. Then another thing is that it can improve the maintainability, because that unit test helps to improve the maintainability of the code by making it easier to understand and modify. So it will serve as a document on like how the code should behave, making it more easier for other developers to understand why another developer writes this code here. So that's the meaningful for this improve maintainability. So the last thing is that it also improves the collaboration, because it allows the developer by providing a common understanding of the expected behavior of the code. So it will reduce the misunderstanding or promote some communication issues during developer do the development related things. Okay, another white box testing technique is the code review. Code review will pay attention to the logics, the design, the coding practices, and as well as the performance, safety issues, and some other related things. Pay attention to here is that the code review is not just done by the developer side. It should also be done from the QA side, because as a quality assurance engineer, what we do is not just a tester. The early we go into from the development stage, the fewer issue will have for this system because it will have more high capability. So let's see what will benefit from this, because it will definitely improve the code quality, and it will help the developer and the quality assurance engineer to do the knowledge sharing, because code review will be an opportunity for developers to share their knowledge and expected experiences with another one, because developers can learn from each other's code and gain a better understanding about the best practices. So it will be pretty meaningful here. And it also will improve the stability and the standardization, because if the code review will be done manually, daily, and in every requirement, it will help the developer to have these things in their daily work. So it will be pretty important. They will know what others do. They will know better mode to write the code, and better mode to process similar issues. So it will be a good learning experience here. And also it will have early detection of defects, bugs here. So like the unit test, unit test and the code review often have this benefit. So that will be this part about this code review session. So now let's move on to the gray box testing technique. Gray box testing is more like the combination of black box test and the white box test. So it will cover both what white box have and what black box have. But we need to pay attention to that. For each system, we need to get a deeper and deeper understanding about this system. We need not only do the scenario analysis, we need also do the code analysis, do the DB analysis, do the overall framework analysis. So that's why gray box testing will take a lot of time if you want to understand and test the system better. Okay, I will use an example here to show what a gray box test work. So let's see, it's an image classification system, because we need to test an image recognition by using both known and unknown images. So first of all, we need to obtain a data set of known images that are properly labeled and categorized for the image recognition system to be tested. This is what we already know the result here. And next, we need to test the image system with to ensure that it's actually identified correctly by this system. And we also need to create a separate data set with unknown result here, and to use that unknown result to test this recognition system again. And after we do all these things, we will analyze the result of the testing and identify any discrepancies and or errors in this system to do the analysis about the unknown images. And we need to combine obtain from the gray box testing process to improve the image recognition system and reduce errors in its classification of unknown images. So this will be a simple example here to what a gray box testing actually works, because in this system there is some result we already know, and there is some result we actually doesn't know. but no. So we will use this unknown things to do the recognition again, and using the known result to do the analysis. So it will be likely of a combination. So let's see what we will get. So it will have better code coverage because let's test coverage, because let's see, because it's a combination of both black box test and the white box test. Definitely we will test have better and higher coverage than either technique. And it also reduces the test time because, for example, let's see if we already know what developer changed in this system and in this new requirement, and we will also know the effect of this change. So it will be faster for us to do the test and to write the test cases, because we don't need to cover everything here. We only need to test the things got affected. And it will also have early defect detection, which we don't need to see here. And it also improves the test effectiveness, affects the security, and improves the collaboration. The most important thing is that it's cost effective, because when we do gray box testing, we don't need to know this system like as deeper as a developer side. But we need to know about the framework, but we don't need to know totally almost everything. So it will save some time here, but we actually know this system, so we will have better test design and better understanding, and we will know what will have issues in this system, and which part will be more possibility to have some bugs here. So it will be cost effective. Okay, that's all for this technique part. Now, let's move on to the last part. It's the skills required to be a good tester. But what we could talk here is that it's more like not just for good tester. It will be also pretty important during your daily work study, no matter you are a tester or no matter you are a developer. So I think all of them should be pretty important if you want to do in this system. So let's see, the first and most important thing is that the critical mandate and the analytical skills. Why I see it important here is that I want to use an example to show you, because let's see, if you are testing a mobile app for a company, one of these app's feature is to show the real-time location on a map. You notice that the vehicle location is actually not updated as frequently as they should be, and that some cars are not being displayed on the map at all. So let's think what we need to do to debug these issues and try to reproduce these issues here. Because by using your critical mandate and analytical skills, you will need to investigate in these issues, and there may be some process you will encounter. The first of all is that we need to gather the data. You will first gathering the data on this issue by observing the app's behavior, review the error logs, and talking about with the development team that you found these issues, but you currently haven't know the reproduced steps. So you will need to talk with them about what we may occur here. And you also need to consider the factors such as the app's data usage, network connection, and some server load to think about why it has this scenario here. Then we will need to analyze the data. Because once you have gathered the data, you begin to analyze it, you will need to identify the patterns and the potential causes about this issue. You will also need to use tools such as the log analysis and the network sniffers to help with this process. Then let's go to the process part. Because we also know about and analyze this problem, and then we need to think about why it happened. So because based on the analysis of the data and the development hypothesis about this cause of this issue, because for example, you might assume that this problem is occurred due to the network issue or the server overload. And after that, we need design and run test, because you have assumed that it's occurred during the network issue, so you need to try to use that conditions to reproduce these issues, so that you will maybe need to test the app under different network conditions or use load testing tools to simulate heavy server usage. Then after that, they will try to and after that, once you find this issue and reproduce it successfully, you will know what determines it here, why it causes here, and you might find that some of the hypothesis is incorrect, and some others maybe need to retract. So you may need to talk with the developer again about what you're finding, and finally you will find out what is the root cause here. What will be the preconditions to reproduce these issues here? Because it will take a long time for you to do the overall analysis here. So by using your critical mandate and analytical skills in this way, you are able to investigate and solve complex issues in this software, because this will help you to improve the quality and the reliability of this app and ensures it meets the usement of the users. Okay. Next one is that the observation skills. Because as the tester, you must be pretty clear-minded and sharp eye. I will use an example, but maybe not so good here, because I will give you 10 seconds to think about how many people in this picture. Okay, let's see here. You can type your answers in the chat. Okay, time up. So you can see that in this picture, there is actually 7 rather than 6, because there is a little boy here. Maybe this is not a good example, but it will let you know, at least let you know how important to observe in pretty detail and be pretty sharp here. Okay. What we also need technical skills. Some students asked before, as a quality assurance engineer, do we need to change code? Definitely we need. So because it may be not just for the developer side code, for the requirement code. We also need, because we also learn the software engineers development, the infra related issues. We need to do some automation test here, because the change is almost every day. If we just use manual test, maybe we can't cover everything in our daily work. So because it will be so hard. So that's we also need, why we need the technical skills to do here. And another thing is that we also need to think about the business domain knowledge, because we need to know about the industry, the business, and then the compliance. Because, for example, if you are a tester in a bank, what you need to know is not just the computer science. You also need to know some finance or economic related issues if you want related information and knowledges if you want to work better in a bank. And as for example, you are a tester in the EY, you also need to know some related to the product things in the background, and you also need to know something related to tax, so that without business domain knowledge, you can't understand the system design better and think more comprehensively and systematically. Maybe you can't output some useful test cases. Because if we just think in a, for example, in a straight mode, because like what we will do according to the different technical, we may miss some business scenario in this way, and some actually maybe some no use test cases we may take some time to execute, and some more meaningful test cases may be ignored in our daily work. That's why we also need to know this part of knowledge. And another thing is that the good communication skills. Think about the example we talked in the critical minded and analytical skills part. If we don't have good communication skills, even after we found out the bugs and the issues, we can't let the developers know the issues clearly because we can't describe the preconditions and reproduce steps clearly. So, and we also need to communicate with different project manager, product manager, and other testers. So it's pretty important to explain things in simple layman terms and pursue the stakeholders and the negotiations here. And another thing is that we also need to pay attention to the project management skills. So know how to be responsible to the stakeholders, resourceful, planning and arrangement, keep an eye on budget and time, and do the team management and do the delivery on time. Think about what James talked before is that QA is almost at the end of the overall SDLC process. So what we need to pay more attention to the project management skills is that we are almost at the end. If we also delay, the overall project will definitely delay. But if we can control the project in a better way, maybe some issues won't happen in this overall project delivery. So that's why we also need to learn some things related to project management, and as well as time management. So because as I see before, as we are the last phase, we must deliver the things on time. If we also delay, definitely it will like the snowball, the overall project will delay a lot. So that's maybe why we will be involved in different stages at the same time and distinguish the tasks in priority and urgency and do a better time management here. Okay, no matter the last thing will be that we need also to pay attention to the process improvement to do the efficiency builder, because no matter by process optimization or by different test tools, or even you can write your own test tools, the only thing we want to do is that to improve the efficiency and reduce the time of the overall overall project. So no matter it's by process or no matter it's by tools, what we only want to is to improve the efficiency. Even we are a quality assurance engineer, we can to write our own test tools to improve it. Okay. That will be all about this sharing about this part of today. Okay, let's move on to the question and answer part.